Thank you very much for the kind introduction. My name is Thorsten Jänisch. I come from the German Aerospace Center's Institute of Combustion Technology. Today I'm going to talk about green aviation fuels or alternative aviation fuels. And I am going to let you in on how these fuels can reduce both CO2 emissions and non-CO2 effects in aviation. But first, let me tell you a bit about the German Aerospace Center, or DLR. We have a threefold mission. We are a research institution, a space administration, and a project management agency. We have about 9,000 employees in 54 institutes and facilities at 30 sites across Germany, and we are active in aviation, space, transport, energy, digitalization, and security. So much for DLR, or the German Aerospace Center. Hydrogen utilization in aviation is a hot topic. Just consider the hydrogen strategy of the federal government or the BDLI's white paper on zero-emission aviation. But how can we get there quickly, as Professor Willner demanded it? How can we defossilize or decarbonize aviation? There are three pillars. Let me start on the right-hand side. The non-drop-ins, such as fully electric or hydrogen fuel cell-based aviation, they have the charm of having zero carbon emissions at all, provided the electricity is green, no soot, no PM production. But the downside is that you have to change both infrastructure and the actual aircraft. If we move to the left, we are at the near drop-in segment. This requires just a minor upgrade of existing fleets. This takes us to liquid fuels, sustainable aviation fuels, or SAF, which are 100% carbon emission free, and they lead to low pollutant emissions. And on the very left, we have drop-in fuels that can be used in existing aviation fleets, in existing infrastructures, and in line with ASTM D7566, they are certified and fully compatible with existing regulations. They give us an 80 to 100% reduction in carbon emissions, and as I'm going to show you in a minute, they will also achieve other reduction aspects. Of course, we want to have 100% emission reduction, but it has not yet been certified as yet. It is fully compatible, though, with existing turbines, and it can lead to 100% emission reduction. Now, looking at the timeline, which of the pillars is the one we should bet on? Well, there is not the one single right approach. Probably the fuel cell and electric aviation, due to the long development cycles, will make its way into this world only from 2050 onward. When it comes to the near drop-ins, we may expect them to set in at 2030, but we have no more than 7 years to go. We have to take action now, and that's why we become active. We actually develop drop-in fuels, and we do research on them. Let me give you a quick example of what drop-in fuels are all about. You have an oil production point, you refine the oil, and you can fill it into every turbine or engine, no matter whether the aircraft is 10 or 20 years old, and the same thing is true for SAF fuels. You just change the force, biomass or green hydrogen, and you have sustainable aviation fuel, and you can actually refuel your aircraft as it is, giving you a direct and quick effect. How do you get there? Well, it's not something that comes off the cuff. Fuels are very complex. They have to satisfy many requirements. They have to burn efficiently, and that's why we developed our in-house fuel design process starting at the synthesis of the fuel, looking into the chemical composition, the physical and chemical properties, such as density, viscosity, etc. And the combustion is observed. We look into the mechanism, emissions, performance in the combustion chamber and in the engine. And together with our partners, we work on optimizing the fuels under research. A demonstrator project and actually a model project is the so-called ND2 NDX campaign, NDMAX campaign, ECLIF 2. We tested various fuels, did emission testing both on the ground and in the air. You can see the second aircraft following the first one, measuring the condensing strips, and if you use HEFA and add it to the reference fuel, it leads to a reduction of the soot emission. Interestingly, if you admix 30%, you get a better fuel soot reduction than if you add 49% of HEFA. So we can attain a more than 60% reduction in carbon emissions. So sustainable drop-in aviation fuels take you quite a long way. As I said, we looked into various fuels, including carbon-based Fischer-Tropsch fuels, which are not much different from the other fuels later on. We have HEFA fuels, conventional fuels. We measured them in the during flight and on the ground measuring campaigns. You have less sulfur, less NOx in the emissions, and a direct correlation could be found between the soot emissions and ice particles, and this has an impact on cirrus cloud formation, and this actually contributes to global warming. And we said, okay, this is a great outcome. With sustainable aviation fuels, we can actually cover non-CO2 effects as well as carbon emissions. Next, we have the fuel prescreening process. Approval is expensive and time-consuming, and if it fails, you have lost a lot of time and money. We don't have time to lose, and no one wants to spend money on nothing. So that's why we have opted for carrying out a pre-screening, looking into the fuel chemically and physically. We actually set up a database, the SimFuel platform, that enables us to simulate the fuels, predicting the properties, carrying out combustion tests, and enabling us to make a forecast as to whether this fuel is eligible for meeting the requirements. And if need be, we will do some optimization work with our partners so the approval process can be passed successfully. What does it look like in real life? Well, let me talk about the P2X Copernicus project. We work on this together with various project partners. We set up an FT oil, or created an FT oil with alcohols and N-alkanes with only little isoalkane proportions. So this is not suitable for aviation engines. We said, okay, let's get rid of those alkenes and alcohol. We tried various processes such as hydrocracking, hydrotreatment, isomerization, etc., and we see a pure N-isoalkane mix in the C range. This is the carbon distribution, and we have almost met all our targets. Most of the targets have been met, and some are still to be clarified, but we are nearing the approval of the first carbon-based fuel, CO2-free fuel. So we want to include all those involved, all stakeholders, fuel producers, aircraft and engine performance, airports and consumers. We want to keep further optimizing the fuels in order to enable them to go for efficient combustion, economic production. Carbon and non-carbon effects should be reduced as markedly and quickly as possible, and we want to ensure that the dream of 100% renewable fuel flights becomes a reality, and we love supporting the authorities and institutions defining the specifications for such fuel. And that's the end of my presentation. I hope I've been able to explain to you that drop-in sustainable aviation fuels take you a long way to do a lot of good in the next 7 years in the way of reducing carbon emissions as well as non-CO2 effects, but a lot of testing and approval work is lying ahead of us. However, I'm quite confident and I am ready to take any questions you may have.